So we are going to the next chapter, chapter number 2, pair of linear equations in two variables. A pair of linear equation in two variable can be represented as a1x plus b1y plus c1 is equal to 0, where x and y are variables, a1, b1, c1 are constants. And the second equation will be a2x plus b2y plus c2 is equal to 0. So this represents a pair of linear equation in two variables. There are two variables x and y, two equations. That means there are a pair of equations linear. Why? Because it is linear as degree of x and y is 1 and the graph of these two equations will be straight line. So if I draw graph of these two equations, I will be getting a straight line, and if I get two straight lines, there can be three conditions. Either the lines can be parallel or the lines can intersect at a point, otherwise the lines can be coincident lines. Okay, so three cases arises, otherwise both the lines will be parallel, either they can intersect or they will be coincident. If the lines are parallel, there will be no solution. If the lines intersect at one point, there is one solution. And if the lines are coincident, there are infinitely many solutions. Okay, again, by checking the pair of linear equations, we can identify how the lines are. Either they are parallel or intersecting or coincident. How it is? Just take the ratio a1 by a2, b1 by b2 and c1 by c2. If a1 by a2 equal to b1 by b2 equal to c1 by c2, then the lines will be coincident lines. Okay, there will be infinitely many solutions. Since there are infinitely many solutions, the system can be said to be consistent. The second case arises when a1 by a2 not equal to b1 by b2. When a1 by a2 not equal to b1 by b2, we are getting intersecting lines. There is one solution, and since it has a solution, the pair of equations is consistent. And a third case arises in which a1 by a2 equal to b1 by b2 but is not equal to c1 by c2. Then the lines will be parallel, there will be no solution, and the system will be inconsistent. Okay, so we are going to check whether the given system of equation is consistent, inconsistent, whether they are parallel, intersect at a point, etc. So I am going to take the first pair of equation as 5x minus 4y plus 8 is equal to 0 and 7x plus 6y minus 9 is equal to 0. So find a1 by a2. a1 by a2 is equal to 5 by 7, b1 by b2 is equal to minus 4 by 6 and c1 by c2 is equal to minus 8 by 9. How is the condition? a1 by a2 not equal to b1 by b2. So what we can conclude? The lines, if a1 by a2 not equal to b1 by b2, the lines intersect at a point, it has one solution and is consistent. Since a1 by a2 not equal to b1 by b2, we have to conclude that the line intersect at a point, it has a solution and is consistent. If we move to the second equation, second pair of equation, let us take the equation as 9x plus 3y plus 12 is equal to 0. 18x plus 6y plus 24 is equal to 0. Same way find a1 by a2. a1 by a2 means coefficients of x, ratio of coefficients of x. 9 by 18 which gives you 1 by 2. What about b1 by b2? b1 by b2 is 3 by 6 which is again 1 by 2. c1 by c2 is 12 by 24, that is also equal to 1 by 2. So what we are getting, a1 by a2 equal to b1 by b2 equal to c1 by c2. Therefore, if a1 by a2 equal to b1 by b2 equal to c1 by c2, they are coincident lines. There are infinitely many solutions and the system is consistent. If a1 by a2 equal to b1 by b2 equal to c1 by c2, the lines coincides with each other. There are infinitely many solutions and the equation system is consistent. Moving to a third pair, third example, let us take the equation as 6x minus 3y plus 10 is equal to 0 and 2x minus y plus 9 is equal to 0. Same way find the ratio. a1 by a2 is 6 by 2 which gives you the value 3. b1 by b2 is minus 3 by minus 1 which gives you the value 3 and c1 by c2 is 10 by 9. So how about the ratio? a1 by a2 is equal to b1 by b2 but not equal to C1 by C2. How is the condition? If A1 by A2 equal to B1 by B2 not equal to C1 by C2, then the lines are parallel, there will be no solution and the system is inconsistent. If A1 by A2 equal to B1 by B2 not equal to C1 by C2, then the lines are parallel, there will be no solution and the system is inconsistent. Okay.